Thanks, Diane. My name is Marcel Hild, and I'm working in a group of Red Hat's Office of the CTO called the AI Center of Excellence. And obviously, we're looking into all things AI related, and I'm specifically focused on the broader theme of AIOps, what it means for Red Hat and the general community. So in the past years, we managed the problem of ever increasing demand for computing power and applications in general by separating the concerns inside the data center. We needed to support a high-paced environment asking for agility in application development and operations. So changes to applications were driven by the developers, and they changed their systems multiple times a day if you look at continuous rollouts and continuous deployments. So what we did, we disconnected the components and brought them together via microservices again. And if you look at it, the same concept applies throughout the whole stack, like distributed compute, distributed storage, distributed applications, and orchestration of services. And with cloud-native tooling such as containers and Kubernetes, we're basically able to infinitely scale out. And obviously this comes at a certain price. More components mean more complexity. But then, hey, in IT operations, in the DevOps world, we need to know when something isn't working. And we need to know it now because we've committed to those 5 nines of uptime SLA and stuff. So to control these complex systems, we need to introduce some sort of instrumentation, some telemetry is required. And so we produce more metrics, more logs, more stuff. And again, we do this at every layer of the stack because every persona brings different needs. Developers need stack traces. Operation folks need latency and timeout metrics. So how can a single human possibly comprehend such a system? We're creating complex systems of rules, alerts, and thresholds. And guess what? We can't keep up with updating our alerts because the systems being monitored change at a faster pace. So it's a classical cat and mice problem, so to say. But in our case, we're in luck because a smart person once said, every repeatable human task that is governed by a probabilistic relationship between input and output will be subject to automation at some time. And to be fair, with all the AI hype nowadays, that's the current state of the art, where it boils down to exactly this. We're training the computer to do very specialized tasks. We excel at seeing patterns in huge piles of data with millions and millions of input features. And to the uninitiated, it might look like magic, but at the bottom, it's a classification problem. If input A, then output X. And actually, we're doing this in all these fields that have a great and powerful monetary background, like showing you the most relevant cat images, or with a great media coverage, like beating human players in almost every game out there. But what about operations? What about ops? And I think here we're just starting to apply all these techniques to our very own special field. So in other words, if your website is slow because your storage is slow, a computer can tell you that. And even better, if your website is slow because somebody flipped a bit somewhere in a not so distant system, with sufficient input and with sufficient training data, a computer can also possibly tell you that. Yes, your website is slow, and if you flip this bit back, it's going to be fast again. So what's AIOps anyway? Gartner coined this term like some years ago, And it goes like this. AIOps platforms are software systems that combine big data and AI or machine learning functionality to enhance and partially replace a broad range of IT operations, processes, and tasks, including availability and performance monitoring, event correlation and analysis, IT service management, and automation. There's a lot of words in there, and I've provocatively highlighted these words, AI replaces IT operations, because people tend to think like this, but like it replaces truck drivers at some point. Although the self-driving cluster will probably be marketed sooner than we think, I don't think that IT operations will be replaced anytime soon. But we will certainly use big data and machine learning to support our monitoring and automation needs. It's just that. It's just another tool to make you more effective and efficient, a tool to support us and not to replace us. And indeed, this is something that we as Red Hat believe in, and we are invested in it. This is another good quote from one of our team members. The key next step for systems management and software development is the replacement of heuristics and fixed limits with learned models. That's by Ulrich Trepper, also from our CDO office. And so not only for operations, but also in our development processes, we have to apply that piece of machine learning supports too. Again, this is how Gartner describes an AIOps platform. At the center, there's big data and machine learning, and then it's a cycle of continuous insights being delivered to these three domains here. Monitoring in the upper left corner will benefit from smarter alerting and like dynamic thresholds as seen before. The service desk will move from a reactive to a more proactive engagement model with higher efficiency when it comes to troubleshooting and stuff. And ultimately, your actions are highly automated and at some point with less and less human interaction. And I think this perfectly aligns with the four phases of AIOps. So first, without data, you're nothing. So data is the new oil. And so we need to get our data collection straight. We need to make sure that we have systems that emit the required telemetry and that we're able to store it for a longer term than just your 2 days of retention period. Plus, you need some tools for visualization. Via images, you convey meaning, and a log file entry that might be obvious to you, the author of that log emitting system. But what about all the metadata in that entry? How do you paint a broader picture over time? Then we need some tooling to help us discover patterns in that data and help us understand these patterns and correlations. Because, make no mistake, there won't be a one-size-fits-all solution for everybody. You will still need to assist the computer, and the computer will support you in your understanding of that problem domain. You're still in the driver's seat. And after learning from the past, you want to apply your knowledge to some future events. You want to know that your application needs to scale out before you actually hit all that traffic. And last but not least, you finally want to know the reason why something is failing, like on the spot or post-mortem. This is the classic needle in the haystack problem. Let the computer guide me to that flipping bit that caused my outage somewhere. And I think what we're all currently missing is a larger community for AIOps. So in every emerging technology, we're seeing a multitude of projects and products addressing similar problems with different approaches. And I mean, this is good. Variety is like the spice of life. But remember the complexity of our problem space, like how many components need to talk to each other. And I think we need also to be at least aware of each other discuss and share our experiences and our reasoning why we took specific approaches. And then by finding ways to collaborate with each other, be it by integration of projects or products, or maybe even creating open source projects that solve a common problem, and ultimately leading to standards that define the way our machines collaborate, like standards how to run things, standards how to talk to APIs, or how we store and query data. And I think here we can build on the success of the operations community, where slowly standards like open metrics or open tracing are emerging. I even think we can accelerate the speed of adoption of such standards and common open source tooling by having a voice in the definition of such standards. And I think a SIG is a great way and place to do such a thing. And with that, I would like to open it up for discussions.